what I'm going to take you through today is important. And if you have any questions about the assessment that is online, ask me about 5 minutes before the lesson, and I'll clear your questions out, okay? And I'll tell you where to prepare any questions if you have. But what we are going to learn today is one of the most important skill that you require throughout maths. All right. Now, let me put it this way. This will come up definitely in GCSEs. This is going to come up in A levels and even real life situations as well. All right. This is what we call as, oops, substitution. Substitution, all right? But before we get to substitution, we have to understand why we are doing what we are doing. How many of you guys have done simultaneous equations at school? Have you guys had a chance to know what it is? Simultaneous, have you heard of it, guys? Anyone? No one? You don't think so? Okay. It's going to come up. So we have to make sure we are ahead. And when this is uh, you have no idea. Okay, no worries. This is something sort of new for you guys. So this is our Cartesian plane, the x and the y axis. Very, very simple stuff. Now, remember in our previous lessons, we have learned how to draw a straight line. Do you guys remember this? Like you would plot 2 or 3 points and you would just join them up with a ruler, drawing a straight line. Even we also worked out how to look at the gradient, the rise over the run. Do you guys remember that? The rise over run thing? Did I cut off? Okay, I'm not too sure on that. Okay, yeah, you remember this? And we also looked at the y-axis intercept c value. Do you guys remember that? Yeah. So, what we're going to look today, just before I continue, guys, um, am I, uh, are you guys able to see me, hear me? There's no issues with the internet at all, right? Yeah, all okay? Could you just confirm, Arya? I think it's possibly from your end. I don't think there is any issue other than that. Okay, it was lagging a bit. Oh, okay. Um, I've checked it. Just a second, guys. Yeah, my internet is very, very fast. But let's see anyway. Uh, are you guys able to see me writing 1, 2, 3, 4? Okay, perfect. Possibly I'll get rid of that. There we go. Okay, so this is our line here, and I'm gonna call it line one. Okay. Now, this line is made up of, do you remember we said these lines are made up of infinite number of points which are the solution to that line, the x and the y coordinate. Do you guys remember that? So let's take 1 point here, that's 1 point, and that 1 point would have an x and a y coordinate, correct? Which should satisfy that specific equation, right? So this is a straight line. Now we're going to talk about interaction between two lines. So two lines can be parallel, just like that. They are parallel to each other. They're never going to touch, even if you extend them to infinity. Are you with me on this? Everyone, just say yes if you understand it. So even if you extend them to infinity, they're never going to touch. Something like the railway lines, but in reality, the railway lines would cross each other, right? They're not straight lines all the time. They curve out as well. But the idea, you get the idea. So they have the same what? What do you guys think they will have? Atati, you got it? Okay, they will have what? The same slope. Okay, what is the other word for slope, guys? Sai, correct. Arush, yeah. Mera, gradient, absolutely. So they have the same gradient. If two lines are parallel, they have the same gradient. But if two lines are not parallel, which I'm saying, they're never, they don't have the same gradient, all right? So they don't have the same gradient, they are going to intersect, all right? So this is line two, and clearly they are not having the same gradient or they are not having the same slope, correct? They're not having the same slope, so they are going to touch at some point. Now, do you see this common point? It's kind of like a junction where two crossroads are crossing each other. That point will have a x and a y coordinate. This would be the x coordinate, and that would be the y coordinate. Are you with me on this? Are you understanding the concept? So there is one point. Now, this is a very unique point. But what is speciality about this point is this point is common for both lines. That's a point which lies on line 2 and line 1. All right, it is not the y-intercept. It's not like the c-intercept. It is like the junction where those two lines specifically meet. The y-intercept is where one of the line would meet on the y-axis, right? Just like that. But this is different. It is not necessary to be on the y-axis. This can be anywhere. That one little, what's going on? That one little point could be anywhere. Is that okay, guys? So this one point is a simple point where two lines are intersecting. Did you guys get it? Now, my point is, listen to me now. This is very important. You see this line 1 will have an equation and line 2 will also have an equation, right? There are different equations for it. This one point will satisfy both equation. And that is the whole idea of this lesson. And I'm going to show you how that is going to work out. Okay, so when two lines are going to come together, we call it simultaneous equations. All right. So when you guys you have two at the same time, Anusha, exactly. So we have simultaneous equations. Simultaneously, this one point is going to satisfy both the lines because it's a common point. Are you guys with me on this? Okay. Okay. Now, throughout your GCSEs, like year 9, 10, and 11, you're going to learn three methods to solve this. So, what do you mean by solve for simultaneous equation? Solve means find x and y coordinate of that point. Do you see this one? We want to find where is that point. We are going to locate that point. That is the meaning of solving simultaneous equation. Is everyone clear on that? So you understand what it means to find simultaneous equation. You're finding x and finding y. Simple. Now we have three methods to do it. Number one is the graphical method. It's super easy. Just like how you see over here, you will draw the graph and find out from the graph where they are going to meet each other. Okay? That's the graphical method. So you always need a graph paper and draw on it and find out where it is going to meet. Number two is substitution. Okay? And number three is elimination method. Okay. Now, elimination method is an year 10 concept. You guys don't need to worry about it. But today we're going to cover graphical and substitution method. Any questions so far? All good? Thumbs up? Yeah? Hello, Lorraine? Yeah? Kashish? Exam style question. 2 marks. Fire away the answers, guys. Okay, so let's go through this first. Use these graphs to solve the simultaneous equation. Do you see that? All right. Yeah, elimination in year eight. Not too sure. Maybe your that could be a different method. All right. So we are given with equation one. This is equation one. This is equation two. And in this specific case, they have already given you the graph. So what do they mean by solve? I told you, what does solve mean? To find where they're meeting, correct? What do you guys think the coordinate of this point is? What is the coordinate of that point, guys? That's the answer. Absolutely. Sorry, you got it. Anyone else? -2 and 4. Simple as that. 2 marks. By the way, this is an exam question. This is like not the filter question. This kind of come up anyway, and you can straight away get 2 marks. Easy, isn't it? Okay, look at this. They can have a bit harder equation. You see this equation, they look kind of scary with fractions, but that doesn't matter because the graph is given to you. But in this one, it is slightly trickier. There is a keyword here. Do you know what that keyword is? Let's go through this. The graphs with equation that and equation that have been drawn on the grid below. Nice. They've already drawn it for us. Using the graph, find estimates. What does our word mean? Estimates. Excellent, guys. You picked it up before me. Estimates. What does that mean? You're not going to go exactly very, very dead accurate, but you're just estimating. Okay? A guess from the graph. Absolutely. So, what do you guys think is a good estimate for this? I'm just going to go up right there and kind of there. What do you guys think? So the x coordinate is someone said 2.5. No, no, no. I want you guys to look at it. 2.5 would be here. This is 2.5. So do you guys think that would be 2.25 or 2.3? All right. So I'm going to say 2.25. That should be all right. And over this one, I'm going to say 1.3, -1.3, definitely. -1.3, guys, the signs. So now, you know the estimate questions. In the mark scheme, this value will have a range. That could be between 2 to 3, not 2 to 3. That would be between 2.2 to 2.3, roughly 2.2 to 2.3. So if you're within that range, you should grab the marks. Any questions? Did everyone understand this? Just say yes if you did understand this. This is coming for exam. Hmm, this seems easy. Now we're building on it. Quick, far away this one. Quick one. Sumaya, what happened? This one, we're just picking up the point. That's all. That is your x coordinate, which is 3 and 4. That is your solution. 3, 4. That is what we call as the solution. So I want you to observe the key part. Diagram shows a straight line on the grid. Write down the solution. You see that? So I don't want you guys to be confused when it says write down the solution. It's where it meets. Cool? Happy? Okay, so we just covered the graphical method. Now the graphical method, oh, I have one more question here. These are all past exams, so I just collected them, guys. I will leave them, some of it. Absolutely. So I have a question. Anusha says, a graphical question will always give 2 lines. Not necessarily. We're coming to that. Okay, so this is 2, 4. Easy to pick it up. What about this one? -2, 1, isn't it? -2, 1. Everyone agree with that? Okay. Now, in a graphical question, sometimes 1 line is missing. What does that mean? You can't have 3 lines. Don't worry. Okay. You can, but that's an A-level concept when you deal with X, Y, Z. There is 3-dimensional. Okay. Don't worry about it for now. Now, so 1 line is already drawn for you. You got to draw another line and then find it out. So that could be a type of a question. So part A, on the grid, draw that. Do you guys remember how to draw? I made a table. We used to do this. So I don't like this table, but I'll go with it for now. So this is the equation we are solving. I'll put x and y. If x is 0, if I replace x as 0 here, y would be what, guys? Y would be minus 2 times 0, which is 0 as well. If x is maybe 1, if I put x as 1, y would be minus 2. If x is, let's say, 2, all right, I'm putting x over here as 2, y would be minus 4. Is that okay? Everyone? Yeah. Okay, now we're gonna plot that points over here. So 1 is the origin. 1 minus 2 is here. 2 minus 4 is right there. And I'm just going to somehow join those lines. Oh, look at the accuracy of it. Nice, I like it. So this is our y equals to minus 2x line. Is everyone with me how I drew that? So these 3 points which we plotted. Why are we going for 2 points, guys? I mean, 3 points. Why not 2 points? Why should we draw 3 points all the time? Uh, Accuracy. Do you know why? Because what if one of your point was wrong? Let's say one of your point was correct, another point you draw it wrong here. There's no way you can know. Then what is going to happen? You're going to join it like this. Do you get me? But 3 points will not be wrong. So if one of your point is not on the line, in the straight line, you have it's kind of a backup plan. Exactly. Okay, it's kind of like a backup plan. So always go for 3 points. All right. So what is the solution here? This is um, minus 0.5 and 1. That is minus 0.5 right there. Are you guys with me? Okay, so you would write minus 0.5 and 1 just like that, and you got a 4 mark done for you. Okay, Arish, we're just getting to that. That is a substitution method. Okay, is x and y where the two lines meet? Yes, that is the solution where they are going to meet. Okay, excellent. Now, look at this. Uh, to You see, this a graph is given, but it's useless graph. Do you know why this is a useless graph? Can you guys guess why this is a useless graph? Mm. Arya, Aditi, Anusha, there is no numbers. Absolutely, there's no numbers for you to read out. So this graph is given just for a namesake. So this is a problem. And then we are getting to the substitution method. Okay, so I'm going to teach you with a few examples. Oh, I didn't mean that white page. Just a second, guys. Okay, there we go. Uh, Add a page. Okay, cool. So I'm going to teach you what substitution means. Substitution is simply replacing. Watch this. If I just say A equals to B and then B equals to C, do you guys think I could write A is equal to C? What do you guys think? Why is that? You know this equation. This was explained by Abraham Lincoln on equality. All right, it's a very nice equation. I love this equation. So we have a common thing here. They both are equal to B, and therefore it's equal. A must be equal to C. A very common mathematical statement. Okay. Now I am saying to you guys, there is one equation. I'm going to write one equation here. Y equals to 2x plus maybe y equals to 5x plus 3. Okay. And then I have another equation. y equals to 2x, mhm, 2x plus 12. Okay? These are two separate equations. So this is equation number one, equation number two. Do you see, just like this, we have both equation equal to y, correct? So according to what I just explained over here in yellow, do you guys agree if I write 5x plus 3 should be equal to 2x plus 12 because they both are equal to y? Did you understand it? That's it. That is substitution. That's the concept of substitution. So you can substitute anything into whenever you have equations, substitution is always there. Now, is everyone with me? No sleeping? Are you guys not tired? Yeah? There's something very important we did. In one step, we did two things. With me, everyone? Yeah? How many variables are there in this equation and in this equation? How many variables? What are variables? Variables are x and y, right? Yes, Anusha, we are just going to do that. Okay? Variables are x and y. Now, there are two variables in this one and in that one, two, x and y. But when we combined it, how many variables are in there in this one? Just one. That's it. No, so Arias, someone said four. There are four terms. I'm talking about the type of variable. Only x is there. Do you get me? Okay. There are these are called terms. They're not variables. So there are four terms, but the variable is x. The idea of solving an equation is always bringing it into one equation with one variable. You can never solve an equation with the two variables in it. There are two equations. We have to bring them together with one variable, and that's why we are substituting it. Did that make sense, guys? So now another important thing that I want you uh, to digest right now, that this step to that step made a logic. So there's in every single step of maths, there should be logic. If maths is not built upon logic, you will make mistakes. All right. And this is where, I don't know. We are building the very foundation of algebra here. So did you guys, all of you, got the logic here from those two to this? Yeah, you got the logic. Now we can solve it. So what I'm going to do, the idea to solve this one is to keep all the x to one side and all the numbers to one side. So 3 goes there, 2x goes here. So can I write 5x minus 2x equals 12 minus 3? Was that all right? I just grouped it. And remember, when a term goes to across that equal to sign or the bridge, I call it, the sign will change. Absolutely. So this is going to be 3x equal to 9. And then what are we going to do? We're going to divide both sides by 3 to get x on its own. So the 3 and the 3 would cancel. X equals 9 by 3, which is 3. Everyone, happy? What is this x equal to 3 now? That is the x coordinate of the point. We didn't draw the line yet, but we have two equations here. Are you with me? Okay. Now we're not done yet. We're not done yet. Why? Because we only found the x. We have to find the y. So I want you guys to pick one equation from here. Okay. Now we are going to substitute x again to find the y. I'm going to pick this equation. Y equals 5x plus 3. But do you see this x equal to 3? I'm going to put that here. So y equals 5 times 3 plus 3. Y equals 15 plus 3. Y equals 18. So what is the coordinate, guys? 3, 18. Substitution method done. Are you guys clear with this? We'll do lots of examples now. By the way, you might be wondering, do you know what? This goes all the way to A levels, all the way to A levels. Now, this is an easy substitution. We have equation number one right there, equation number two right there. This is super easy. Okay. It is called, Asvika, yes, it is called substitution because we substitute. Absolutely. So you know what? This x is already given. One of it is already the answer. So x equal to 6 is already the answer. Now we're going to replace. So you see that equation number one, I'm going to rewrite it. X plus 5y equals 16. And I'm going to replace this x as 6 over there. So 6 plus 5y equals 16. I'm going to move that 6 to the other side because we want to make y the subject. So 5y equals 16 minus 6. I'm writing every single step. And y equals to 2. So 6 and 2. Done. Kashish, yes, absolutely. Absolutely. Correct. Now, we didn't even draw the diagram, but we found where those two lines are coming. How did you know to add x instead? What do you mean? Like replace it? Yes, Sai, that is the 6, 2 is the coordinate where they're going to intersect. Do you know what? Let's check it. Let's actually check it. 1 second. This is x plus 5y equals 16, x equals to 6, okay? So I'm going to go out to our, I love this app. We'll come back, guys, just a second. Mm, is the numbers visible to you guys? Yeah? I'm just going to type in the same equation. It was x plus 5y equal to 16. So that's the line. And our second line is x equal to 6. There we are. That is it. Do you see the intersection point? 6, 2. Sumaya, that was just a question. It was given to us. Anusha, did this make sense? So we have two lines and we just worked out the intersection point without drawing the line. And that is through substitution method. Let's come back. So that's what we did over here. Okay. We have, can everyone try to work this out? X is already given, by the way. X value is already given. That this is a easy question which I picked up for you guys to initially get it correct. So replace X over there. Okay, someone got the answer already. Anyone else? Okay. All right. A few answers. Charan, do you want to check it? Double check. Okay, few of you guys are getting. Anyone else? Anyone else? Absolutely. Okay, I'm not just saying the answer, guys. All of you guys are, whoever typed it is so far correct. Okay, amazing, amazing. What are we going to do? We will write 6 here. So 6 plus 3y equals 18. We will move that 6 to the other side to make 3 y the subject. Okay, Lorraine? Okay, in case if you got a wrong answer, don't worry. Just see what went wrong. So 3y equals 18 minus 6, 3y equals 12. And then what do we have to do? We got to divide both sides by 3. So y equals to 4. Y equals to 4. So in case if you made a mistake, see, check where it went wrong. And if you haven't done this, written it and did it in your head, now that's a problem. Don't do that in exam, okay? Don't do those steps in your head and just say the answer. Your likelihood of going wrong is even more. So this is 6, 4. Okay, guys? Now, I want to go, I'll leave this to you guys. These are easy questions. But I want to get to something, this one. I should have put some more space over there. We'll come back to this one. Give me a sec. How about this one? Slightly hard. And I want you guys to please stop writing now and pay attention on the screen, okay? So I'm just going to rewrite it. It's kind of crumbled up. That's our equation number one, equal to 6. So we have two equations here, right? I'm going to name these equations. This is equation number one and equation number two. Now there's a problem here, okay? We don't know what to replace. Atati, yes, you're right. Okay. What do we replace to what? In such cases, they are not equal to the same things. In such cases, we will find the variable which is alone. In which equation, which variable is just on its own? Type in equation EQ1 or 2 and which variable? Which variable, guys? Which variable is just on its own? Anusha, correct? Yes. Um, 3 mark the 3x, the variable x is the variable, right? So in that case, when you look at it, it's not just on its own. Here we got y on its own without a number with it. Make sense? So that's the one. So I'm going to pick this equation. Watch what I'm going to do. I have 3x plus y equals minus 4, correct? How can I get y on its own, guys? I'm just going to move that 3x to the other side. What do you guys think? So can I write this as y equals minus 3x minus 4? All I did is move that to the other side. I didn't do anything else. Okay? Now, I am going to replace this or substitute it instead of that y. Got it? How many of you didn't understand it? Just say if you didn't understand, let me know. This is crucial. Okay, let's go back a step. By the way, this is the same equation as the first one. All I did, I made that. So you have, what was the first step? You identified y, which is alone. Okay, Fatima, you found out what was on its own, just on its own. So let me go to a different question. In this one, which variable could you make just on its own? You could make this y, you could also make this x. No problem. It's up to you. What do you want to do? Got it? Some would make y, some would make x. No problem. But there are two options in this one. Are you with me on that? Did you get it now? So what is it? What about the next one? In this one, there's only one option. What is that option? Absolutely, this x. You would make that x the subject. Okay? All right. What about this one? In this case as well. Ooh, let's just keep on moving. Um, X as well. Are you guys with me on this? Absolutely. Now you got the idea. So let's come back to the question which we were doing. So I took this same equation. I made y the subject. Now I am going to replace this in the second equation. That's all. Because I have y. The y value for both equations are the same. Got it? So the new equation, the second equation, I'm going to rewrite it. 3x minus 4, but instead of y, I'm going to write minus 3x minus 4 equal to 6. Are you guys all right with that? You see, instead of this y right there, I wrote that, replaced it, because y is equal to that. Arush, did you get me? Because y is equal to that. Y must be the same thing. Do you get me? It's just replacement. Yeah. Okay. Now, What is special about this equation, guys? I told you, whenever you want to solve, there is something special about that equation. What is so special about it? We have one what? Only variable. One variable, which means you can solve it. Okay? So what is a very most obvious? Have you guys all done expanding the bracket? Expanding the bracket, we did it a while ago. Do you see a bracket right there? So just expand the bracket. That's it. Do one step at a time. So you see this -4 would multiply inside the bracket like that. Is that step okay? But you got to be very careful with your negatives, all right? What is negative times negative? Negative times negative times. It would be positive, right? Okay. So I have the 3x. This -4 multiplied with -3x would become positive 12x. And this -4 multiplied with that -4 would become positive 16 equal to 6. Are you with me? Just expanded, only one step at a time. Now, I'm going to add those two. Why can I add those two? They're like terms, isn't it? Yeah, they're like terms, so I can add them up. And at the same time, can I move this 16 to the other side? The number goes to the other side. So I'm just grouping all the terms in one go. Now, some of you might not have seen so many arrows. When your teacher is explaining, they don't explain with arrows, right? Uh, Let me show you. How many of you guys have seen this specific method? I'll explain to you in just a second. So I'm adding this 3x and 12x to get 15x equals, you see the 6 minus 16 would give me, what is 6 minus 16? 6 minus 16, as is correct, everyone? Minus 10. So this is minus 10. And therefore, we have x equals minus 10 over 15, which can be simplified to minus 2 by 3. Okay, now I'm going to take I'm going to take this step here. Um, how many of you guys have done just like this in school? You might have, so this is the extra bit I'm doing. 15x plus 16 equal to 6, okay? Now, you might have done minus 16 minus 16. How many of you have done like that in school? And then you would write 15x equals minus 10. Yeah? You have done. You see, that method is valid. But when you have so many operations, you can, using this method, you can only perform one thing at a time. Make sense? Which this is a slower method. I would recommend you, I'll show you some other method which you can do multiple things at the same time. And all you need to do is stick to a couple of rules. That's it. Okay? And you will be much, much faster if you can just do it. Did everyone understand what happened here? Yeah? Okay, we're nearly there. We're halfway there. So this one question, I want you guys to lead me. Arya, you will get it very well. 5x plus y equals to 21 and x minus 3y equal to 9. And I'm going to number this as equation 1 and this is my equation 2. Which equation um, do you want to work out? I mean, which equation do you want to work out and why? What I meant is that was not the right wording, guys. Just a second. Which variable? Do you want to make x or y the variable? Uh, Someone said x, someone said y. Why do you want to make y the variable? I'll tell you why. You got to be a bit clever here. Okay? Watch this. You see, if I make y the subject, I have to take this 5x to the other side. Agree? Yeah? So that will become what? Minus 5x. I don't like minus numbers. Negative numbers are always confusing. You know, it adds to the problem. We don't want that. But what if instead I move this to the other side? You see that minus 3y becomes positive 3y now. All right? There's no negative at all then. So watch this. Equation 2 can be written as x equals 9 plus 3y. Or you could write 3y plus 9. Would you agree? Okay, got it? Okay. Now we are going to substitute. Boom. No, that was wrong. Substitute here. Are you guys getting this? So you took one equation, made the variable the subject, substitute in the other. Cool stuff. Now I'm going to rewrite that 5. Instead of x, what should we write? Can you guys type in? Instead of that x, what should we, instead of this x here, what should we write? 3y? Not 3y. 3y plus 9. Absolutely. Mark, are you getting this? Yeah? Plus y equals 21. There you go. Now, this stuff is equation in one variable. You can now solve it. What is the very next obvious step, guys? What is the very next obvious step you need to do? Expanding the brackets. Absolutely. Expand. So that would become 15y plus 5 times 9, 45 plus y equals 21. Clear steps. Now, I'm gonna do, this is why, remember I wrote down a step before and I told you I will teach you a faster one. You're doing two steps at the same time. I think, Fatima, I think, watch what I'm doing. You see this 15y and y. I'm gonna add them up. Why am I gonna add them up? Because they are the like terms. They have the same variable, same power. At the same time, I'm gonna move that 45 to the other side at the same time, both happening at the same time. So this would become 16y equals, what is 21 minus 45? Minus 24. Straight away, simplified. Are you with me, guys? Yeah? Okay, now what do? We got to divide both sides with 16 in order to make y the subject. So we're finding y equals minus 24 divided by 16. How can we simplify it? This would be minus 3 by 2 by simplifying it with 8. Ta-da! We're done with y. So y is found. Y is found. We're going to find x now. For x, you see this equation here? You take that same equation and work with it. So we have x is equal to 3 times, instead of, we're substituting in again, by the way, we found y as minus 3 by 2. So instead of this y, we're going to write what? What do you guys think? We will, instead of that y, we're going to write minus 3 by 2 plus 9. You guys with me? Yeah? So when you add this up, this is a multiplication of fraction now. All right. Can you guys just tell me what would this be? Just type in the chat. I want to see your multiplication of fraction skills. Oh ho. Okay. Um, okay, Charan, correct. Aditi. Aditi, you have an issue there. Need an easy method. Okay. Sai, correct. Anyone else? Do you guys have issue there? Aria, no. No, no, no. Okay, gap in knowledge. You guys need to, we gotta go back to multiplication or fraction at some point. But watch this. I'm just gonna quickly add something. You see, if you have, ooh, so if you have x over um, x over y times m over n, when you multiply a fraction, you multiply the numerator to the numerator, denominator to the denominator. So this xm over yn. Okay? Just like 2 by 3 times 5 by, I don't know, 7, this would become 10 over 21. Clear? You just multiply straight. That's it. But you can have this written in different forms. Let's say you have 2 times, sometimes it's written 5 by 7. Remember, this 2 means 2 by 1. Do you guys see that? 2 means a number by 1. So you could write it like this, and this would just become 10 over 7. Do not do, if it's written like that, don't assume the 2 will multiply with the 5 and the 7. No. So this is not correct if you write it 10 over 14. Is everyone with me on that? Yeah, got it? Okay. Now, the same thing, if I write 2 times 5 by 7, it is the same thing as we write 2 times 5 by 7 like this as well. It's both the same thing. The multiplication, the bracket shows multiplication itself. Okay, so when I come back here, what does this mean now? X equals minus 9 over 2 plus 9. Clear? Happy? Okay, now we gotta make a common denominator. How do you add this to? So we're gonna make 9 means 9 by 1, multiply by 2 and 2 to make a common denominator. Only then you can add this up. So this is minus 9 plus 18 whole divided by 2. So the answer is 9 by 2. Excellent. So what was your final answer, guys? 9 over 2 and minus 3 by 2. How many of you guys get this? Okay, well done, well done. Now, do you know what? Sometimes some year 11 students don't get this. They struggle. All right, so I want you guys to now practice 9 by 2 minus 3 by 2. Let's come back to that question which we ignored, which was this one. So in this one, it's not a graphical method, although the graph is given. Now you have your tricks under the sleeve. You know what to do. Y equals 4x minus 5. Y equals 2x plus 1. What should you guys do? Huh? Yeah, we don't need to make a y or x the subject. We don't need to do that. You can literally equate these two because both of them are equal to y. So 4x minus 5 equal to 2x plus 1. Got it? Everyone? Yeah? And then keeping all the x together, numbers to one side, we have 4x minus 2x, 1 plus 5. Notice the only thing I've done it all in one go. You see that 2x, when it went to the other side, it became minus 2x. You see this minus 5, when it went to the other side, it became positive 5. Done. Okay, so that is 2x equal to 6 and x equal to 3. Now what do? We pick any of the equation as you like. I'm gonna pick this one here. So y equals 4x minus 5. And do you see this 3? I'm going to substitute it into that x. Y equals 4 times 3 minus 5, and y equals 12 minus 5, and y equals 7. Absolutely. So this point right there, it is 3, 7. Are you guys clear on this concept? The graph was just there, you know. Just sometimes they give you the extra information just like that. So the graph was just there. The graph didn't serve any purpose. How do you find this topic? Medium. Good. Okay. All right. You got. So, guys, when I tell you this is a very important topic, I want to take you to um, my ultimate good notes. Just a second. I'm going to go for this is a past exam paper booklet. All right. This is the maths past exam booklet with 700 pages, something like that. I'm going to search the word solve. Are you watching this? We don't need to do elimination just now. So I'm going to pick this question up. Ha. So by the way, these are proper higher tier past paper, okay? Everyone? Oh, this looks a bit I think is this the one we did? No. Hold on. I don't know why the answers are already here. That could be the process of me solving it. Um, how do I get rid of it? I'm so sorry. Yeah, there we go. Let's solve this one, guys. It's a past exam question, really quick. Worth 3 marks. You're now in exam. Did we do this one? Oh yeah, we did this one. Of course, we did this one. So now you can see where I'm getting the examples from. We did this one. I think we made X the subject, isn't it? Absolutely. You guys know where I'm getting the questions from. So sorry. So let's find solve once again. Oh, come on. Yes. So there are even further solves, but the instead of solve, I'm going to type in simultaneous. It's the app is just taking its time to show me the questions, guys. But do you see all these pages have simultaneous equations in there? That's one. Now, hmm, what would be the answer to this, guys? We did this question as well. We did remember to find the estimates. Do you guys remember that? One of the one which we kind of estimated it. That was a 2 mark past exam question. All right. So this question is slightly different. This is where you don't need to worry about it for now. I don't know how to get rid of that tab. I'm so sorry. This app just went through a update, and I'm not liking the update that much. But anyway, do you see what is the problem with this equation? What do you guys think? There are two equations, but there is a problem with this. Not y is negative. There is no one variable on its own. Remember, they all of them have there's no one variable. When I say one variable, there's no x or y just on its own. They all have some sort of numbers with them, and that is what is making them a little bit hard. Absolutely, Aswika, you can do so many different methods to do it. Okay, there are so many different methods. So I want to come back to our slide. And remember, I told you this one here, we did the graphical method, we did the substitution method, You see the elimination method? We don't need it for now. The idea is to, because you guys are in year 9, graphical and substitution is perfect, but you need to be a master at those two. Don't learn all the three methods right now and you forget them. Make sense? So you need to be really good at graphical method, sorted, substitution, sorted. You do a lot of practice and you're a master of substitution and you're good to go. Okay? That's what you need to do. Any questions for me? So now I want to tell you about the assessment. So when you go to your platform, you should be seeing your assessment. Is everyone aware of the masterclass on the platform, or is it for the first time? Because sometimes some of your accounts will pop up as you have not logged in into the masterclass. How many of you guys are not aware of the masterclass? Okay, so this is how your dashboard is going to look like when you log in. Have you logged in? So please log in. Okay. And then I know you guys are getting, a lot of you guys are getting into this one, the white shirt, me, year 9, the one which is just there. But there is something like this called a masterclass. Do you see that? If you click over there, all the lessons, everything is animated for you guys in here. Please go through it. Any topic that you want to look at anytime, it's here. Say, for example, what we covered today is linear equation in two variable. So this is going to explain solving graphing linear equation in two variables. This will teach you 18 and 19. So if I go there, 18.3a is simply going to, in 6 minutes, it's going to visually teach you what to do when you have a graph. All right, remember this? The 3 points, we made 3 points. So that is explained here. Simultaneous equation, exactly as I'm covering here in detail, it's covered here. So solving by graphical method, you click on it and then you will see this lesson running on for 7 minutes and you should be all right. Oh God, I look different. All right, so you're plotting. I'm solving many questions in here and you're plotting those solutions. Are you guys with me on this? Do we have another exams in assessment? Yes, yes. So, and at the bottom, I have solved a few couple of questions. It's a very short video, so there are 4 examples solved below it. And the substitution method is just explained over here as well. So I would like you guys to make use of this resource that you have. So it is clearly explaining everything that you need to do step by step. So the process is explained. 1 second. Somewhere here, the process was explained in detail. Every single step is explained. Okay. And you have exam style questions right at the bottom. You can go to the elimination, but it's up to you guys which method and why, so you can understand which method you need to use and why are you using graphical. Let me come back. Where is that? I think somewhere here. So we have graphical, substitution, elimination method. Did you guys get it? And for the homework, now, just a second. For the homework, you go back to your dashboard. You will only see this. I have access to all of it. You click on this, and then you would, oops, scroll down. Today's lesson is simultaneous equation. You can see lesson notes and homework. Do you see those two PDF right at the bottom? This one, that one there. Okay, you click on it, you will be able to download it, and this is your homework. You can print it out and solve it. And in just 1 or 2 days, I will be uploading the answers to this. And if you guys know this, you should be all right. So everything that you need is here. By the way, your assessment is here. Try these. So this assessment 1, do you see assessment 1? I have clicked, I've written a prerequisite. So do you see this part, loss of indices I have written the reference to the master class. All right. So section 13, 15.1a. This is referring to the masterclass which I just showed you. If you go through that short video, which shouldn't take more than half an hour of preparation, you guys should be all right. And click continue. You will go to your assessment here. What is the right answer for this one, guys? Tell me quick. 5 square. Who did that? No, 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 Arish, think about it. It's 200. Click confirm. And so on. There are about 22 questions. Once you have done this, this will automatically update to your profile and it will tell me what you made mistake and what you didn't. All right. And then I can get back in touch with you. So this assessment is based on these lessons anyway. But if you don't have time to watch all that lesson, you just need to go through the masterclass. It's going to teach you everything you need. Oh, any questions for me? Rationalize mean, at the bottom, um, it could be assert. You're just making it not assert. That is what we mean by rationalize. You're bad in the exam, even if we have revised. Then I will be in touch with you, Samaya, and just help you out how you can improve. Remember, this exam is not about how good or bad. This is picking up your gap in knowledge. That's all it's doing to me. And then the lessons can be tailored to it, and then I can get in touch with you, etc. There is no simultaneous equation in the last test. So simultaneous equation will be coming for the next one. Okay, so the assessment is here, guys, here inside the platform. Are you guys clear with this? Anusha, we don't. If you have any questions, that's why we push the video solution because it would be too hard for us. There's no correct system in place to communicate with the PDFs. That's why we push the homework lessons. All right, guys, I hope that was useful for you guys. So I will see you next week. Until then, take care.